Welcome back to Geometry Summer Prep. We're going to pick it up today with Lesson 7. We're already on Lesson 7. So let's jump in and take a look at this. If you look through the notes, now I made a little side note up the top here. You must know some of this vocab in order to do this lesson. So if you haven't looked at the previous lesson, Lesson 6, go do that first. Otherwise, you may be kind of lost when we use some of these words, okay? So I'm not going to do a deep dive into their meaning right here. Just go watch that other lesson first. All right, and then if you take a look at these notes, it's a lot of words. It almost doesn't look like a lot of math, but you'll notice in geometry, you will have some units that have a lot of words, and you'll almost be like, this doesn't look like math. In fact, there's a whole unit over logic that you do pretty early on in the year. And it's just a very different type of math. But the reason for that is geometry is more than just shapes. It's also very much logic and reasoning. So this is going to have a lot of vocab here, but it's a very, very important vocab too. The types of problems you're going to see on the notes in the practice today, I promise you will see again in the future. In fact, I also do tutoring for SAT prep. I was just doing that yesterday, and there was a girl who was stuck on a problem because it involved this stuff and she hadn't done it since geometry. So all very important information here. All right, let's dive in and learn some of these new vocab words. Okay, so first off, it says, we're talking about this first word, which is called a transversal line, okay? It's nothing fancy, it's very basic actually. A transversal is a line that intersects two or more lines, okay? So in our example here, if you take a look at the picture, you've got three lines, right? If I said which one is considered the transversal in this picture, you would say line T because that's the one that cuts through the other two, okay? So line T would be a transversal to lines L and M. All right, so for the example, we'll just say line T. Line T, that is our transversal line. So nothing crazy there. Let's look down here. So you'll notice you've got 1, 2, 3, 4, 5 big vocab words or terms right here. I want to start, actually, we'll save this one for last, and we'll start right here and work our way down, okay? Okay, so it says off to the side, angles formed by a transversal. So if I zoom into this picture here, take a look. We have, well, try to determine what would be considered your transversal line. Look at the three lines. And if you said T, you are correct. Is that the same as the other one? Yeah, that's the same picture with just angles. So that was a pretty easy one. Okay, so this is our transversal line. Now, whenever you have a transversal that cuts through two or more other lines, you create a bunch of angles. As you can see here, we've got 8 of them, right? There's 4 up here and there's 4 down here. And they all have special angle relationships and we give them specific names. So let's go over them. Let's start with alternate interior angles. And actually, before I even show you what that is, I kind of want to edit these last two. So, okay, it really depends on who your teacher is and what kind of geometry class you're in, but 9 times out of 10, your teacher will not use this word. Okay, I'm actually going to cross out the word consecutive. They might use it, so you may not want to black it out and keep that on your notes, but what I've noticed most of the time is teachers tend to use this as the word, same side interior angles and same side exterior angles. And I prefer that too because that's just so much easier than saying consecutive interior angles. All right, so we are going to use same side interior, okay? Okay, so really the big difference here, if you kind of ignore corresponding angles for a second, you've got alternate angles and same side angles. Let's take a look at what just that part means in determining which is which. All right, if I picked a couple of example angles here, so I'm going to pick like angles 4 and 6 for just a second. I want you to always locate your transversal line first. So here's my transversal. Now tell me, would you say those two angles, 4 and 6, would you say they're on the same side of that line, or are they on opposite sides? Well, they're clearly on opposite sides, right? So they're not going to be like a same side angle pair. These are going to be opposite sides, aka alternate sides. So alternate really does just mean opposite. They are on alternate sides of the line. All right, so that leaves us with 4 and 6 is either going to be alternate interior or alternate exterior. Let me show you now how to determine that part of the term, okay? So again, we are looking at 4 and 6. We know it's alternate something because they're on different sides of the transversal line. To determine interior or exterior, you look at the other two lines. So I'm going to highlight this one and this one. Take a look at those two lines. Are angles 4 and 6 in between them, or are they outside of them? Well, they're definitely in between those two lines. So this is going to be interior for that reason. If they had been out here and out here, they would be exterior. Okay, so we determined 4 and 6 would be an example of alternate interior angles. So over to off to the side, they want you to list the angle pairs. So they give you two lines because there are two pairs of them. So the first one, I'm going to say angle 4, and I'll just do a little and symbol, and angle 6. All right, so try to guess what the other pair of alternate interior angles would be here. So we know 4 and 6 is one of them. What would be the other pair? Can you see it? Maybe take a guess. Okay, I'm going to show you. So if I draw my transversal line again, the other pair of alternate interior would have to be angle 3 and angle 5 because they're on opposite sides or alternate sides. And then if you look at these two lines, they're the other two that are on the interior of them. So we'd say angles 3 and 5 would be the other pair. Angle 3 and angle 5. Okay, hopefully this is making sense to you. Based off that, if that did make sense, you might be able to figure out all the rest of these now, but let's go through them. Okay, let's look at a pair of alternate exterior angles. All right, so if they're alternate, that means if I look at my transversal, they're on opposite sides, and they're in the exterior of the other two lines. So an example of this would be like angle 1 and angle 7. Opposite sides of the transversal, and then if you look at these, they are both on the exterior of them. They're not in between the lines. Okay, so angle 1 and 7. Can you see the other pair? It's going to obviously be angle 2 and angle 8. Okay, so let's write those ones down. 1 and 7 and 2 and 8 would be my alternate exterior angles. 1 and 7, 2 and 8. Okay, let me write it down. Angle 1, angle 7, angle 2, angle 8. All right, so that covers all the alternate ones. Now let's look at the same-siders, as I call them. We got same-side interior and same-side exterior, and then we'll finish it off with the corresponding ones. We'll go back to the top. Okay, same-side interior. Let's break that one down. We look to our transversal always first. And angles on the same side, well, there's a bunch of them, but let me pick two to show this to you. I'm going to pick 4 and 5. Those are clearly on the same side of the transversal, right? And then if we look at these two lines, they are also still on the interior of them. So 4 and 5 would be an example of same side interior. And if you can tell, the other one's right next to it. It's going to be angles 3 and 6. Okay, so 4 and 5 and 3 and 6 would be our same side interior angles. Let's see, 4 and 5, 3 and 6. 4 and 5, 3 and 6. Okay, and then let's take a look at our same side exterior. Y'all can probably guess what those are for now, or from everything that we've talked about. Let's look at our transversal. And I'll go ahead and give you one of them. It's going to be angle 1 and angle 8. Those would definitely be on the same side of that line. And then if we look at these two lines, they are on the exterior of them, right? Nothing's on the interior. These two are on the outside of them. Okay, so angle 1 and 8. Can you guess the other pair? You probably can. Same side exterior would also be angle 2 and angle 7, right? They're on the same side and they're still in the exterior of these lines. So 1 and 8 and 2 and 7. Okay. Angle 1, angle 8, angle 2, and angle 7. Okay, so hopefully those are going well. Let's look at the last one. It's kind of its own thing. They're called corresponding angles. And you could read through the definition and maybe kind of figure it out. It says angles on the same side of the transversal and in the same position. Let's see if we can make sense of that, okay? So this would be like, let me show you what this is like. A lot of kids get confused by this one because they may tell you something like, hey, angle 1 and angle 5, classify them. Something like this. Actually, this probably pops up in your practice sheet. Classify that angle pair. Okay, well, let's look at them. Angle 1 is right here, angle 5 is right here. Let's see if we can figure this out based on everything we've learned. Well, I know I need to look at my transversal. They are on the same side, so maybe they're like same side interior or same side exterior. But do you see what the problem is here? If you look at these lines, are they interior or exterior? Well, one of them's on the interior, right? 5's on the interior, but 1 is on the exterior. When this happens, don't be fooled. It's not one of your same side or angles. These are what are called corresponding angles. And to make sense of the definition, if we zoom out, it says angles on the same side of the transversal, like we just saw, and in the same position. So if I can do some colors on here to show you this, this will make more sense to you. See how 1 and 5 correspond, 2 and 6 correspond, 4 and 8 correspond. I need one more color. Purple. And then 3 and 7 correspond. Like visually you can see that, right? They're in the same position. Like all of these up here are in the same position of all of these down here, like the color coordinated ones. So like if you look at the green ones, right? Just look at the green ones right here. They're both on the left side of the transversal, and then if you look at their individual lines, they're both above their individual lines. So we say they're in the same position, so they're corresponding. Okay. Hopefully that made sense. I know the corresponding one's kind of weird, but if you notice, there's more examples you can always give with corresponding because there's always going to be 4 sets of them instead of like 2 pairs of them. So let's fill that in. So we just said angles 1 and 5 correspond. Let's write that down. Angle 1 and angle 5. We said angle 2 and angle 6 correspond. And then we said 4 and 8. Oops, an angle. That was really bad. 8. Hopefully yours is better. And then our last one was 3 and 7. Okay, and that is like the meat of the notes. I know that took a little bit to get through, but we're going to do, like this entire example is going to be based off of that. And then we'll have one other little thing on the other side, and the rest of the examples are going to be based off of all these notes. So let's zoom in and look at an example here. Okay, it says name the type of angle relationship. And then it says if no relationship exists, write none. I don't think that'll happen actually on any of these. So we're just naming the type of angle pair. So this example, if you look at the picture, it's similar to the one up here, but it's kind of like turned a little on its side. So be careful with this. Can you identify what your transversal line is here? Well, it's going to be line R. So this is what we're going to look at for our transversal. Okay, so let's jump into it. Example A, we've got angles 1 and 8. Okay, let's locate those. Here's 1, here's 8. So they are definitely on opposite or alternate sides of the transversal. And then if we look at the other lines, so we're still looking at 1 and 8, look at the other lines, they're not in between them, right? So they're going to be on the exterior of those. So this is going to be alternate exterior angles. And I like to abbreviate because that's a lot of writing. So I'm going to put Alt-X, just like that. Okay. Next one. And if you want to try all of these and then play this back and see if you got them right, go for it. All right, we're talking angles 2 and 3. Let's locate it. Here's 2, here's 3. I'm going to look at my transversal. They are on the same side of the transversal and they are in between these lines. So this is going to be same side interior angles, which I'm going to abbreviate as SS int. Same side interior. Hopefully that makes sense to you. Okay. Next one, we've got angles 5 and 7. Let's locate them. So angle 5, angle 7, you may want to look at your transversal line. And be careful on this one. They are on the same side. However, one of them is in the interior, right? One is in between the lines, and then one of them is out here on the exterior of them. So this is going to be our corresponding angles. If one's interior, one's exterior, and they're both on the same side of the line, that will always be corresponding. Corresponding. I guess I could abbreviate that one, but I didn't. Okay, angles 2 and 7. Let's check them out. Here's 2, here's 7, here's our transversal. They're definitely on alternate sides of it, and they are in between the two lines. So alternate interior. Alternate interior. Okay, next one, angles 1 and 3. Let's see, okay, 1 and 3. Here's our transversal. They are on the same side, but same thing as the one a couple problems up. One's on the interior, one's on the exterior, so this is going to be our corresponding. I'm just going to end it there. And then angles 5 and 8. Last one here. Okay, let's locate them. 5 and 8. They're definitely on the same side of the transversal, and if you look at these two lines, they're both on the exterior. So same side, exterior. SS, exterior. All right, hopefully you guys have a good feel for that. Let's go ahead and look at our last part of the notes here. So we've got some stuff up here, and then these are really just 2 examples with like kind of multiple parts, but we'll get through those pretty quick. All right, let's jump in. Now, this side is just a little bit different because we are now talking specifically about parallel lines. If you notice the pictures on the other side, there's no parallel lines, right? We just have like 2 random lines that aren't necessarily parallel. So when you have a problem like this, where you don't have parallel lines, you can name the angle pair like we just did right here, but there's nothing special about the measures of the angles, okay? Now, when you take those 2 parallel lines and those 2 lines and you straighten them up to make them parallel, maybe something like that, then you end up with a lot of very special relationships in the angles. So we're going to look at that now. So this one's all about parallel lines. Okay, I'm going to do this. I'm going to group these first 3 together, and then I'm going to group these 2 together. You'll see why. It says if 2 parallel lines, I'm going to underline that, parallel lines are cut by a transversal, then you're going to end up with special relationships. And I grouped these 3 together because they all end with the same word, okay? Corresponding angles will always be, if you have parallel lines, they will always be congruent, which just really means equal measures, okay? Same for alternate interior angles and alternate exterior angles. They're all congruent. Okay, now the only ones that are weird, and we might as well cross off the consecutive word, we're not using that. The same-siders have a different relationship, okay? Same-side interior angles are not congruent. They are what we call supplementary. And hopefully you remember what that means from the last lesson. That means that they add up to 180 degrees, okay? Same thing with same-side exterior angles. They are also supplementary. And I know you don't have this memorized yet, but it shouldn't take too long because basically they're all congruent except for the ones that are the same-siders. Those are the ones that add to 180. Okay, and then it does have a bonus little thing here saying, recall from unit 1 or our last unit that vertical angles are always congruent and angles that form a linear pair are always supplementary. That will be helpful on a couple of these. I'm anticipating this one and this one to be ones that involve these words right here, okay? Those ones are going to be a little bit weird, so if you aren't familiar with those words, definitely look at the last lesson and then come back to this. Okay, let's see if we can look at this now with the parallel lines. So directions say, identify the angle pair as congruent or supplementary. So that's what you're going to write for each one. It's either congruent or they're supplementary. And it does say give your reasoning. They love to do that in geometry where you have to like justify your answer. Now, your reasoning can just be the fact that they're alternate interior angles or they're same side exterior angles or something like that, okay? So basically, let's name the angle pair first. We should get that extra practice anyway, and then we'll add the additional, they're either congruent or supplementary. So part A, angles 3 and 5, let's locate them. Here is 3, here is 5. Well, we know those are on opposite sides and they're in the interior, so they are alternate interior angles. So I'm going to start with just putting alt int and then put a comma, and then what does that mean then? Since we have parallel lines, you can look up at your notes, but alternate interior angles are always going to be congruent. So that answers that. They are congruent. And more specifically, that just means like if they told you angle 3 is, I don't know, 30 degrees, then you already know angle 5 is also 30 degrees, okay? Which if you forget like, oh wait, which one is it, congruent or do they add to 180? I mean, you can really tell, y'all. If you zoom in, does angle 3, I mean, it's a small angle, it's an acute angle. Doesn't that look the same as angle 5? That's also a small acute angle. So you can usually tell. Let's take a look at angles 1 and 8. Here's 1, here's 8. Let's see, these would be on the same side. And then if you look at the other two lines, they're on the exterior of them. So let's label that as same side exterior. And then if you can look back up at your notes, what does that mean about them? Since we have parallel lines, well, same side exterior angles are supplementary. So that answers that. I'm just gonna put sup. And also, y'all, use logic and reasoning. If you totally blank on a test and you forget, oh, I don't know which one it is, well, take a look at them, guys. Angles 1 and 8. Look at angle 1. That's like a smaller acute angle. Look at 8. That's like a bigger obtuse angle. Well, they don't look congruent to me, right? And if they're not congruent, they're supplementary. So there you go. You can use logic to get you through that if you don't remember them. All right, angles 2 and 6. Let's locate them. Angle 2. Angle 6, they are on the same side, but one is interior, one is exterior. So what are these? Corresponding. I'm just gonna go like that. Corresponding. And then we can look at our notes if you're not sure about that one. Corresponding angles, those are always congruent. Basically, the only ones that are not are the same siders. Okay, so congruent. Congruent. All right, definitely try some of these on your own too. G and H will be a little tricky. G and H, you will not use any of the words that we learned today. You'll use different words that we learned last time, just to give you a little hint there. Okay, angle 1 and 7 for D. Let's locate. Here's 1, here's 7. They're definitely on opposite or alternate sides, and they're both on the exterior of the other lines. None of them are on the inside. So we say alternate exterior. Alternate exterior. And we just learned, you can look at your notes above, that those are always congruent. Okay, let's keep going through these. We got angles 4 and 5. Here's 4, here's 5. There's our transversal. They are on the same side and they are on the interior. So same side SS interior angles. And our same siders are supplementary. Sup. Now, your teacher might want you to write the full word. I'm just doing this so that to save some time with our note video. Okay, angle 3 and angle 7. Let's take a look at these two. Here's 3, here's 7. There's our transversal. Okay, that's difficult. They're on the same side, but one's interior, one's exterior when we look at these two lines. So these are going to be our corresponding ones. Corresponding. Which means they are congruent. Okay, and we've made it to a couple of our weird ones here. Let's take a look. We got angle 5 and angle 6. Now, if you locate where those are, 5 and 6, they're right next to each other. They're never going to be like alternate interior or same side exterior or corresponding or any of that unless they're pulling an angle from up here and an angle from down here. If they're picking two angles from down here, you're going to be dealing with a different type of term, okay? So 5 and 6, if you remember from our last lesson, those are on a straight line. And if you added those measures together, they would equal 180 because they form a straight line. We call these ones, two angles that are right next to each other on a straight line, we call them a linear pair. So we'd say linear pair, which means they are supplementary. Okay, and then angles 2 and 4, also kind of a weird one, I'll zoom in. 2 and 4 are both up here. They're not on a straight line. Okay, like 1 and 2 are on a straight line, or even like 1 and 4, those are on a straight line. Those would add to 180. 2 and 4 are across from each other. Okay, remember how we talked about in the last lesson, anytime you have two intersecting lines, we'll just look at these two in particular, you always create what's called vertical angles, like right across from each other. And that's exactly what 2 and 4 are. They're vertical, just like angle 1 is vertical to angle 3. And vertical angles are always congruent. So we'll say vertical, they are vertical angles, which means they are congruent. Okay, very good. Last one here, it says, okay, so we're gonna actually do a little bit of math now. It gives you the measure of angle 1, and based off of that one angle, it wants you to find the measure of every other angle, which seems a lot, but these are so easy, y'all. Like, I promise, the easiest problems you'll get, okay? And it does say give your reasoning. We've done a lot of that. Let's go ahead and just talk through it. Let's just write the angle, like the actual degree measure right here, and we'll talk through the reasoning. Don't worry about that part. We've done a lot of that already. Okay, so again, if the measure of angle 1 equals 65 degrees, let's label that. Okay, locate angle 1. And it is 65 degrees. Okay, that's really big. Let's go a little smaller, 65 degrees. Now, what I recommend you do, rather than go over here and like find every angle, I would just look at the picture and label all of the angles and then just translate it back onto your paper. Okay, think about like the easiest place to start. There are so many ways that you could do this. I would maybe look at like angle 1 and 3 first because those are vertical, which means they're the same. So I know angle 3 is 65 degrees. Okay, you could use corresponding angles. You could say, well, 1 is in the same position as 5. Those are corresponding. So those are the same, okay? So 5 is also 65 degrees. For the same logic, 7 is also 65 degrees. I told y'all this is going to be real easy. Okay, those are all of our 65 degrees. Now we have this angle, this angle. We got 4 left to find. And spoiler alert, those are all going to be the same number too. There's a lot of ways you could find it. You might have already done it. I would look at 1 and 2 and be like, okay, they're on a straight line, which means they add to 180. So just do 180 minus 65. What's that going to give us? 115? Yes. 115 degrees would be angle 2, which means, here, you know what? I'm going to do that in a different color. Let's go purple. 115 degrees is angle 2, which means so is angle 4. And the corresponding reason, so is angle 6 and so is angle 8. That's it. And you could go fill all of those in here. Angle 2 is 115 degrees. I think they just alternate from there. 3 is 65 degrees. 4 is 115. Yes, they should alternate in this pattern. I filled them all out on here. I'll let you guys fill them out there. Don't worry about the give your reasoning because we did just check, or we went through that on this part, just talking about it. And that's it. You made it through. I know that was kind of lengthy, but good job, you guys. Hopefully that made sense and you're ready for the practice problems. I will see you on that video.